So I'm going to go over some of the vocabulary from the beginning of chapter 7 dealing with angles and angle relationships. Our first one, of course, is the word angle. I put this here. If it spells gel at the end, that's angel. You want angle. Okay, so if you see gel, that's not how you want to spell it. An angle is actually a measurement of the space between two rays. An array has a point on the end and goes on forever in the other direction. So that would be one ray, and then here's the same point, goes on forever in the other direction. That's an angle. Angles are named in several ways. You can name them by 3 letters, you can name them by a single letter, or if you've got a number in the middle, you can name it by the number. That has nothing to do with the measurement, it's just like a label. So for this one over here, I could label it by its single letter at the vertex or the point, that's angle B. We could label it with 3 letters, angle ABC. Again, 3 letters, but going the other way, angle CBA. Notice for those, the point, the vertex, is in the center of both. And then because this has a 2, I could also name it angle 2. 4 ways to name the exact same angle. Sometimes it depends on the situation. Sometimes you have to use all 3 letters because it would be confusing to just call it angle B. We'll talk about some examples of that. Similarly, over here, we could call this angle ZMR, angle RMZ, or just angle M. This one does not have a number inside it, so we can't name it like angle 4 or angle 2. We only have the 3 options for this. Okay, let's talk about the types of angles when we classify them. This is a right angle. It is exactly 90 degrees. We have this little box that we put in the corner. That's what convinces us that it really is 90 degrees. If that box was not there and this looked like it was 90, I would not assume, because it could be 89 or 89 and a half, that to our eye without a measuring tool looks like it's 90, but it's really not. Likewise, if the angle is poorly drawn and it doesn't look like it's 90, but the box is there, then it really is 90. That's the drawer's way of communicating that they're just not really good and they intended for it to be 90. Think of right angles as perpendicular. That's a word that we use. The corner of a piece of paper, for example, is usually 90 degrees. So that's a really good way to get a good estimate. Is that 90 degrees or am I just seeing things? A right angle. We have something called a straight angle, which is exactly 180 degrees. Now you have to be careful because this can be confused with a line or a number line. You'll tell by context. Sometimes they'll have an arch over top with degree measurement, or they'll tell you angle and give you information. Okay, it's usually done by context. So that is a straight angle. Then we have an acute angle, which is less than 90 degrees. If we compare it to the right angle, it's smaller. Okay, you could fit multiple acute angles in there. And the opposite of that then, if this is smaller, we have an obtuse angle. Now, generally we say that it's larger than 90, but we need to amend that definition a little bit and say that it's between 90 and 180. It's between the straight up and down and the straight side to side. There are angles that are greater than 180 degrees. We won't talk about them this year, but they are. So that's why we have to say it's between 90 and 180. That is obtuse. Now, we start putting angles together. There are relationships between angles. If you have 2 lines that cross, they will form pairs of vertical angles. Okay? Opposite angles formed when 2 lines intersect. So if my lines cross, the angles across from each other are vertical angles. They almost look like V's, right? Similarly, the top and the bottom where I have the squiggly lines, those are a separate set of vertical angles. Vertical angles are congruent, which means they will have the exact same measurement, the same size, the same shape, everything. Instead of writing the word congruent, you can use the symbol, which is an equal sign with a squiggle over top, or if you're familiar with the Spanish alphabet, a tilde. Okay? And the other angle relationship is adjacent angles. And you might have heard this word in everyday life. There's a lot adjacent, a vacant lot adjacent to the park. It means next to. That's exactly what this is. Okay, so if you think about being adjacent to someone in the classroom, the person you sit next to, you're adjacent to them. Similar for angles. These two angles, so I've got a little one here and I've got a bigger one here, are adjacent to each other. They're next to each other. Moreover, they share a side. So if I was to draw this, I would only have to draw that side once. They also have a common vertex, and there is no overlap, which we don't really talk about in middle school, but there are situations where your angles could overlap and then they would not be considered adjacent. Okay, so let's summarize here real quick. We've got 4 types of angles, 4 categories of angles. We've got right, straight, acute, and obtuse angles. Can I get them all in? There we go. Those are the types of angles or the categories or the classification of angles. And then we also have some angle relationships. We have vertical angles, which make the V, and I think of that here like there's the V. And then adjacent angles where they are next to each other. And I always thought of a person named Jason because this kind of sounds like it. And I'm going to sit next to Jason in class. That's how I always remembered adjacent, and then V was vertical. We will do more in applying these and how we can use them to figure out missing measurements in the coming days.